Hello everyone, my name is Bindu M.E. and I am working as Associate Professor in Department of Mechanical Engineering, Lourdes Mother College of Science and Technology. Myself along with my colleagues Professor Jairam B. and Professor Siju K. Abraham is presenting a video on engineering mechanics on the topic moment of inertia. So, in the previous videos, we have seen the calculation of moment of inertia for a composite section. In this video, we will see how to find the moment of inertia of a section which is having a hollow portion. So, the question I have considered it is to calculate the moment of inertia of a given shaded section, and this is a figure given. The dimensions are marked as 6000 and this side it is 6000, it is a square, and inside this we are having a triangular shape with 3000 and 3000 side millimeters. All the dimensions are given in millimeters. Now what is the procedure to find the moment of inertia? So first it is, I have to redraw this figure with necessary dimensions. And then I can divide the section into different individual geometric sections. Like I have divided this into section 1, the meaning it is a square section without any triangular hole. And the section 2, it is a triangle and that is a cutout portion. And then as we did earlier, the first step it is to locate the center of gravity of the whole section. So my colleague has already explained the procedure for finding the center of gravity of this same section in the previous videos. So I am not explaining this procedure in this video. I am taking directly the values of x bar and y bar from that previous video. That is, x bar is equal to 3000 millimeters and y bar is equal to 3000 millimeters. So that means we are to locate the center of gravity here. So this side y, it is a leftmost axis and this is a reference x-axis passing through the bottom point of the section. So I can take this x bar that is equal to 3000 from this y in this direction, and I can draw a line YY. And then I can take this y bar that is equal to 3000 millimeter from this reference in this direction, and I have drawn this line that is xx. These two lines are meeting at one point, and that is the center of gravity of the composite section. That is the center of gravity of the section which is having a triangular hole. Now, before I explain the procedure for finding the moment of inertia, let me ask you to reflect on this. That is, do you have to use this theory of parallel axis theorem to solve this this question? Think for 1 minute and answer it. So I think you have thought about this. Now the answer is, here it is, you don't have to apply the parallel axis theorem as we did it in the earlier problems. So if we write the parallel axis theorem, it will be like this. We are having these two sections 1 and 2, therefore I can write it as IGXX, that is the moment of inertia of the section about this center of gravity. IGXX will be is equal to IG1XX, that is the moment of inertia of the section 1 with respect to its own center of gravity, plus A1 into H1 square, plus IG2XX plus A2H2 square. This is a parallel. If you write the parallel axis theorem, it will be like this. But now what is H1 and H2 in this case? So let us first consider this square 1. So where is the center of gravity of this square 1? That also it has been explained in the previous video, but I'll explain it once again here. So here This is a square which is having a side of 6000 millimeters. So the center of gravity of this section should be at a distance of 3000 millimeters from the y-axis. So this x1 will be equal to 3000. So similarly, this side is equal to 6000. That means this distance must be equal to 3000. That is, y1 will be equal to 3000. That is, x1 equal to y1 is equal to 3000 millimeters. Now I will consider the section 2, that is a triangle here. Now this side it is equal to 3000 and let it be h. So what is the fundamental formula? What will be the distance between the center of gravity and this side? It will be equal to h by 3. So this distance will be equal to h by 3. So that means 3000 by 3. So this side will be equal to 1000 and remaining this side will be equal to 2000. Now you are taking the center of gravity distance between the reference lines. So that means this side 2000 plus 1000. So the total distance it is equal to x2 is equal to 3000. And similarly, if this is equal to 3000, this distance will be equal to h by 3. So that means this distance is equal to 1000. Now this is a reference line, that means 2000 plus 1000, it becomes 3000. So the value of x2, y2, it is equal to 3000. So that means x1, y1, x2, y2 and x bar, y bar, it is equal to 3000 millimeters. So that means the center of gravity of G section 1, section 2 and the center of gravity of the composite section will be the same point. That is G1, G2 and G, it is the same point. Now we'll see what is H1. H1 means there is a distance between the center of gravity of the section 1 and the center of gravity of the composite section. Here it becomes 0. That is, H1 becomes 0. And similarly, H2 means it is the distance between the section 2, the center of gravity of the section 2 and the center of gravity of the composite section. That is also equal to 0. So that means I can write it as this term becomes 0 and this term becomes 0. So finally, I can write it as what? Igx is equal to Ig1xx plus Ig2xx. So that means it is the moment of inertia of the section 1 about its own center of gravity plus the moment of inertia of the section 2 about its own center of gravity. Now I am substituting the formula that is Ig1xx means it is a rectangular section or a square section, so it will be BD cubed by 12. So that equation is written here, and then the moment of inertia of the triangular section, it is BH cubed by 36. And substituting all these values, B1 means this distance is equal to B1 6000, this is equal to D1 6000, and for triangle it is, I have expressed this as B2 and that is equal to 3000. So substituting all these values, I have found out this value of moment of inertia as 105.75 into 10 raised to 12 millimeter raised to 4. Now similarly, applying this Igyy, it will be equal to Ig1yy minus Ig2yy. So again, substituting all these values, I can find out this value as 105.75 into 10 raised to 12 millimeter raised to 4. So this is about this finding the moment of inertia of a section which is having a cutover portion. I hope it is clear to you. Now, thank you for watching. Thank you.